So S3, state S3, input 1, output 1. So S3, 1, 1, input 1, output 1. From S3 to S0, input 0, output 0. So input 0, output 0. Okay, so complete more to Mealy conversion. Okay, next is state minimization. So advantage of Mealy often leads to a reduction of the number of state. Okay, so the number of state can be reduced by using the concept of equivalent states. So two states are equivalent if both states provide the same output for identical inputs. Okay, one of the states can be eliminated if two states are equivalent. Thus, the number of states can be reduced. So this is how the we want to do the state minimization. Okay, so we look into the example state minimization. So minimize the state below. Okay, so we have state V, W, X, Y, and Z. So 1, 2, 3, 4, 5, 5 state. Okay, so we want to minimize this state. So first step is draw a truth table based on the state diagram from the state. Identify the same output for identical input. Okay, so for state minimization, don't change this V, W, X, Y, Z to bit because it's quite difficult. So just draw the truth table by using state V, W, X, Y, and Z compared to by using this is 5 state compared to 000, 001, 010, 011, and 100. So instead of that ones, we use only V, W, X, Y, and Z. Okay. So for state V, input 01. Okay, input 0 and input 1. The next state will be VW. Output is 01. VW output 01. Okay, and then so on. You analyze all these state diagram from input and output like the previous example. So we get this truth table. Okay, so state V is identical with state Z and state W is identical with state X. Input, next state, and output are identical. Okay, so after we get this truth table, okay, so from this truth table, we can see that this state V and state Z, okay, V and Z is identical. What is meant by identical? Okay, so for V and Z, input for sure similar 0, 1. Okay, you can see that from the next state and output. The next state is similar also VW and this is VW. So output is also 0, 1. This is 0, 1. And then you can see that the W state W and state X also have identical next state and output. So you can see that this is the next state for W is YV. The next state for X is also YV. The output is also similar 0, 0 and 0, 0. Okay, so step 2. Because V and Z are equivalent, one of the state can be removed. Okay, because of V and Z is equivalent, so we remove the Z. Okay. Also, W and X are also equivalent, so one of the state can be removed. So X we remove. So just eliminate in the state table. So we remove the X and Z. Okay. Step 3. The row with present state X and Z is eliminated. If they appear in the next state column, they must be replaced by their equivalent state. In this case, the row for state the row for state Y contains Z in the next column. So this is replaced by its equivalent state, which is B. Okay. So before that, uh, before we proceed with this eliminated state, we have to analyze again. Is it from this state, next state contain the state that we have already eliminated? For example, we have already eliminated the state X and Z. Any state X and Z that occur in next state here, so we have to change or replace by their equivalent state. Okay, so we have eliminated X and Z. So this one doesn't have X or Z. This one doesn't have X or Z. This one have Z. Okay, so Z we have eliminated, but Z actually is identical with B. Therefore, we change Z with state V. Okay, so this is the example what's the meaning from this step 3. Okay, after that, we can uh, go to step 4 to draw the new truth table. So because the new truth table contains V, W, and Y only, because we already eliminate X and Z. From 5 state, it will be 3 state only. Okay, V, W, and Y. Okay, so after we get this new truth table, so we can draw the new state diagram from this truth table. Okay, the present state is V, W, and Y. So V, W, and Y. So input for V, state V, input 0, next state will be V. Okay, output 0. So draw like this. Next state input state V, input 1. The next state is W. Input 1, next state is W. Output is 1. So 1. For W, 0, 1, Y, V. Okay, W, 0 will be Y, 1 will be V. For Y, 0 will be V, Y will be Y, input 1 will be also V. Okay, so for 1, 0, V, 1 also V. Okay, and then don't forget to write the output. So we get the equivalent or state minimization for from 1, 2, 3, 4, 5, 5 state. Okay, from this state diagram that contain 5 state, okay, we can minimize to be only 3 state. Okay, VWY only. Okay, so that is how we do the state minimization. Okay, then next is application for Mealy model. Will be discussed in next video. Okay.